Welcome back. Let's take a look at a circular curve question. To recap, we'll be using the following steps to solve this problem. 1. Sketch or refer to the curve as shown in the handbook. 2. Identify given curve components. 3. Solve for the missing component using geometry. The problem states the following. A horizontal curve is designed with a radius of 600 feet and has a tangent length of 150 feet. The PI is at station 200 plus 00. We're going to try to solve for the stationing of PT. The first thing we need to do is to find the horizontal curve diagram from the NCES handbook. A quick search for the word horizontal will lead you to section 5.2 of the handbook. The diagram is shown to the left. Next, we write down all the given information from the problem statement. The radius is given as 600 feet. The tangent length is stated as 150 feet, and the point of intersection is 200 plus 00. First, let's identify our critical stationing relationships. PC equals PI minus T, and PT equals PC plus L. Since we were given T and PI, we can easily solve for PC. Let's plug in 200 plus 00 for the PI and subtract the 150-foot tangent length. We calculate PC to be 198 plus 50. From our PT equation, we see that we need to determine the arc length. The equation is shown below. However, before we can calculate L, we need to find the intersection angle. Here is the equation from section 5.2 of the handbook. Since we already know the radius and tangent length, we can rewrite this to solve for the intersection angle. Plugging in our values, we see that the intersection angle is 0.49 radians, or 28.07 degrees. Now we have enough information to calculate the arc length. Plugging in the radius and intersection angle into our equation, we calculate L to be 294 feet. To solve for the point of tangent, all we need to do is add the length of curve, which is 294 feet, to the point of curve, which is 198 plus 50. This gives us a PT of 201 plus 44. The stationing of the PT is 201 plus 44. Note that you cannot simply add the tangent to the PI. This will result in an incorrect answer. You should not be surprised if they try to sneak something like this past you on the exam. Just beware and keep the stationing relationships in mind.